All right, so we should be recording now. Again, this is Brett Wood with Kimley Horn, and this is the second Park Plus Lunch and Learn of 2014. The intent of this session is to go over the calibration process. We've talked to a few folks at the beginning part of the year, and it seemed like there was some confusion about what was going on with the calibration process, just what was driving that engine behind it. So through a combination of some screenshots and PowerPoint presentation that kind of talks about the calibration process and what goes into it, and then into some actual demos with Park Plus and ArcGIS, showing you some of the new elements of calibration. So our intent today will be to walk through what we've done in the past, how we calibrated your models, and then how we're doing this going forward, so that you'll be able to see this. And a lot of the things we're going to show you are new modules and iterations of Park Plus that are being tested and built out now. And so the intent is to kind of show you these and hope that we can get some of these into your new build-outs for those of you with maintenance fees that have the ongoing patch and upgrade series. So let me just jump right into our PowerPoint here. So today we're going to talk about the calibration process and how that's evolved. What are our critical factors for calibrating? And there are user characteristics, there's parking characteristics, there's occupancy, there's assumptions that go into that. We'll do an example of current calibration, and then we'll talk a little bit about what is next. And as usual, at any point, stop me if you have questions. Feel free to use the IM portion of this meeting if you want to type up a question, and we can stop and go through anything at any time. All right, so the calibration process in Park Plus. Just what is the calibration process? And I think we've explained this to a few of you as we've done trainings, but just as a reiteration, it's taking your land use data and the parking characteristics that are unique to your community. So that's parking occupancy, that's user characteristics, walking distance, mode split, pricing, kind of the allocation between weighting, the allocated weighting between pricing and walking distance, and using all of those factors to relate those land uses and parking together to create a unique set of parking generation factors for your community. So the intent is to get away from using ULI or ITE for prediction of parking demands and rather use parking generation characteristics that are specific to the data that you've collected. And the ongoing calibration process is important because as you calibrate, you're going to start changing and evolving parking demand and land use characteristics in your community. And several of you, City of Lincoln, City of Houston, are currently doing expansions of your model right now into other areas, and the calibration process will be critical there as well to make sure that you're capturing the right relationships and that the data is predicting accurately. So when we talk about calibration, there are a few elements that go into this, and you'll may remember this from your training, but there's time of day. So what are we calibrating to? What time of day, what analysis period are we calibrating to? And those are all factors that you'll go in and manually input as you're setting up the calibration file. Multimodal settings. So how are people getting to and from the community or the campus? And how are those distributed in non-vehicular trips? Parking allocations, and this is actually the most critical piece of calibration, is what are private parking relationships? Are there land uses that only utilize parking facilities? Are there groups of parking facilities that serve a specific user type? Like on a campus, you may have student parking or you may have faculty parking, and you're defining those through the allocation process. And so if you'll remember, there's parking allocation by land use, which is that one-to-one private land use, private parking relationship. And then there's parking allocation by user type, which is going to be that user group system-wide allocation that looks at student parking or employee parking or resident parking and allows people to pick and choose within their pool. And finally, there's model settings. So at what point does the model predict that a parking facility is full? And how does the model distribute the weighting between pricing and distance and overall facility attractiveness? And these let you get into the actual algorithm that's driving the model and weight what is more important to your user as you go through. And so you'll be able to move that slider bar back and forth. And we'll show you an example in a second of how that impacts the calibration process, determining whether or not your users are weighted more heavily towards one or the other. So then we talk about, what does calibration do? Well, so it creates the spatial land use and parking links, and I've got an example in just a second I'll show you, but basically it identifies relationships between parking facilities, whether that's on-street, off-street, surface, garage, public or private, and creates those relationships spatially in GIS, so that now we can go in and evaluate walking distances, we can evaluate specific area-wide demand parameters, and so that's really taking and linking those things so that we can really unlock the GIS capabilities when it comes to analyzing parking. It creates adjusted parking generation rates. So if you go into the attribute table in ArcGIS after we've calibrated, you will see that for every individual land use, there is a time of day adjusted parking generation rate based on the occupancy of the parking and the characteristics of the parking that are surrounding it, that are part of that spatial land use and parking link. And then finally, it sets characteristics for your future modeling scenarios. So once you've got a good calibration data set, you're ready to go in and start building out future scenarios, whether you're looking at master planning or new developments or new parking or parking pricing. The success of those scenarios are built on a good calibrated data set that allows you to really understand that you are modeling accurately within the Park Plus model. So any questions to this point? Okay, I'm only going to show you a couple more slides and then we'll get into the actual look and feel of it, but I just want to make sure we're not losing anybody. All right, so then we ask, how does calibration work? And this is where we're going to kind of see that spatial relationship. So let's take, for example, in your model, you've got a series of land uses. So on our screen, we see these blue rectangles representing our land uses. Each of those have specific characteristics, whether that's a restaurant, a residential unit, an office, and they've all got square footage characteristics or dwelling unit characteristics that are associated with them. Then we add in parking facilities into the GIS. So our red squares are our parking facilities, and within those we've got price, we've got number of spaces, we've got occupancy by hour, we've got whether it's public or private. So when we go to calibrate the model, what's happening in the back-end engine in ArcGIS is that it's creating specific walking tolerances around those parking facilities based on the user input. So as part of the calibration process, we'll plug in numbers for how far people are willing to walk to get to parking. And so it creates these radii, and within those radii it identifies the land uses that would be associated with those parking facilities. And it's creating thousands of these relationships as you go along. And if you create those allocated private parking relationships, it may take a parking facility offline so that it's not creating this radius for those public demand generating land uses, but only for those that it's serving. And once we've got all of these relationships identified within Park Plus, we do a comparison of actual demand. So how many spaces are occupied in the parking facility based on the data that's associated with those facilities, or the counts that were done in the field, versus theoretical demand. So how much parking should a land use need based on ULI or ITE or city or county code, however you set your model to be configured. And so it'll do these two calculations, and based on the difference between the two, we created an adjusted parking generation rate. So it's basically the actual demand and the theoretical demand in a ratio to adjust the demand generation characteristics up or down for each land use. So as an example, typically in a parking analysis, an office may park at 3.5 spaces per 1,000 square feet. But we go in and see that the theoretical demand is actually greater than the actual demand. We will reduce that value so that the generation characteristic is more realistically predicting parking demand based on the characteristics of your community. And so it does that again for every land use, and that's where those adjusted parking generation rates come through in the attribute tables. So then the last thing, how do we test it? So there's been a number of ways that we've tested calibration over the life of the Park Plus model. Initially, we were testing the calibration based on a comparison of facility by facility occupancy. So we'd go in and look at the occupancies on a facility by facility basis to see how closely it was predicting. Over time, that migrated to a more statistically relevant platform where we're now using confidence intervals, mean differences, and standard deviation to understand how far off these are. And again, these are based on principles of travel demand modeling. So in Kimley Horn's other practice areas, we have a lot of travel demand modeling expertise. We brought those into the development of this model to understand how to correctly calibrate this based on those variables. And so now the newest iteration of Park Plus in the current versioning has a calibration engine built into it. When you go in and calibrate or baseline a model, it will give you these metrics at the end and allow you to understand how close your facilities are to actual calibration. And we can adjust that as we go through in an iterative process to get to an acceptable level of calibration. And so that gives us the confidence that we've got the accurate model developed for each of your communities or campuses. So let's take a look at the current calibration, and I'll bring up GIS. I'm going to move it over into the main screen, and in the meantime, I just threw a ton of information at you, but I'd like to know, does anybody have any specific concerns or questions about what we just talked about? Does it all make sense in a general format?
Generally, yes.
Okay. I think let's get in and look at the actual application of it, and it may make a little more sense for you so you can see where we're at. So I've got a new scenario here that I'm working with, and you'll see this is what the calibration screen shows when we're setting things up. And this would be an example of a fairly poor calibration with 36% mean difference and a standard deviation of 17. That is telling us that the model is wildly predicting differences in occupancy versus what was seen in the field. So the average difference is 36%, and that standard deviation is pretty large. So what we're looking for as we calibrate is to get that mean difference below 10% and that standard deviation around 5%, and that should account for some pretty standard variation based on user characteristics or walking that are applied in the model. So there are a number of ways we do that, and let me start with, give me just a second, let's bring up some of the data here. Let's go set our calibration factors to 0. So when you are calibrating a model, and we would have talked about this in training, but when calibrating a model, we'll step through setting up all of the characteristics of that model or characteristics of that scenario so that they mimic what you're trying to model. So in our case, we'll start with the temporal settings, and we'll set the time of day for what we're trying to model. And so in this case, I'm going to set it to the peak hour, 10 a.m. on a weekday. So it's already set that for me. We'll go in and set a mode split for our model. And in this case, I've set up just a general mode split of about 16%. So it's telling us that 84% of the people are coming via car, 16% are coming via shuttle, bus, walking, biking, and some variation. And we have no values for our other user types because we have not created specific user types in this model. So there's no values needed. Our third piece of information is we can go in and set our weighting factor and our occupancy percentage. And so I'm going to set those at the default levels of 85% and 50-50. And then the last thing we would do is go in and set up parking relationships. And I'm going to take these off because I want you to see what happens without them in when we calibrate this model. So everything's saved. All of my settings are set up. So we would just go in like we've done before and go to calibrate. And again, I have no visitor, resident, and employee uses, so I'm just going to set those at 1 foot because there's no users associated with them. And I'll set our general user, which represents all of these land uses, at 500 feet. So we're saying that people that are utilizing these land uses in this block are willing to walk about 500 feet. So I'll click calibrate, and it'll run through the process. The calibration process, like I said, is going through and creating those relationships. It's creating the walking distances between the land uses and the parking facilities, and then it's running the model to look at what a predicted run would look like in comparison to the calibration, and it gives us statistical values to tell us how well calibrated this model is. So as an example, our mean difference is 19%, our standard deviation is 12, and our low and high intervals are 11 and 26. So it's telling me with a 95% confidence our deviation should be between 11 and 26%. And again, that's not a very good calibrated value. And so what we would do is go through an iterative process of looking at those different settings that we created and look at how we can move those numbers down to better represent the calibrated conditions. So the first step that I'm going to do, I'll go back into the allocation screen, and this is probably the most critical step in setting up calibration, is allocating land uses to their appropriate parking facilities. So in this example, this office building right here utilizes this parking facility, and the restaurant that makes up these three parcels utilizes this parking facility, and everybody else is overflowing into the on-street parking around the site. So what we'll do, we'll click create relationship, then we'll go in and select our parking facilities. So the first one I select is the US Air facility, and then I'll select my land uses. And so the office for US Air is allocated to the parking for US Air, not the public parking, but just the office parking. And there's two layers of parking here. One is public, and it serves the other land uses, and then below it, layered in the shapefiles, is the private parking that has the permitted uses. We'll click allocate, and then we'll do the other. So this is our restaurant, and there's our land uses. So we'll select all the restaurants, and it's actually one restaurant that makes up all three parcels, and we'll allocate that to the parking. So now we go in, and we've got the four relationships set up that we had previously. We click save, and let's go through that calibration process again. And our previous calibration had a mean difference of about 19% and a standard deviation of about 12, and we should see a pretty good reduction in those values by using the actual allocations. And the reason that's important is, in real life, those facilities are not going to be available to everyone, and so we don't want the model to begin to predict those as available to everyone. So we see now that by setting up those relationships, our mean difference went from 19 to 14, and our standard deviation went from 12 to 8. So if we were happy with that, we could accept that baseline, and that would become our new calibrated condition that we could build scenarios off of. But we're going to play around with some of the other characteristics and see if we can't get that down to a more acceptable level. So let's try some of the settings. If we change price from 50-50 to, let's say, price at 80, distance at 20, so saying that price is now the biggest factor in the decision point for our users of where they're going to park, we can calibrate this again. And it'll run through that process again, building off of those previous results with the allocation, and now with our weighting factor set to 80-20. So we see we went from 14 and 8 down to 11 and 6. So we're making some moves here, and we're getting this down to more of an acceptable level. What if we went the other direction, though? What if we tried distance as more of a factor than price? We'll try that one more time. And you'll see this is kind of an iterative process, and we're going to go through this for about 10 or 15 minutes, but typically on our side of things, when we're doing a campus or a large downtown, we'll spend the better part of a week going through this and testing different relationships in different settings to get everything right. So we ran that at 80% distance, 20% price, and you see we went the other direction. So our mean difference went from 11 to 15, and standard deviation went from 6 to 9. So we're going to go back to the previous one, and we'll set that. And then let's see what happens if we change this maximum occupancy percentage. Maybe we make that 95% instead of 85%. So we're basically saying now that the model will fill up a parking facility to 95% of its capacity, and once that happens, it starts moving the demand other places. So let's see here. So we'll save that, run this one more time. Nope, let's go back to 500. So we should see a pretty good production here. So now we're back down to 12 and 9 basically. And let's see what happens if we bump that up to 100%. And basically what we're doing is just walking through kind of a stepwise process of looking at the different factors. And again, I'll go back to, allocation is the big one. You've got to get the relationships right, because you can play around with the weighting, you can play around with the occupancy percentages, but if you don't have the allocations right, you're probably not going to get this number down to an acceptable level. So we went up again on that one, back to 13 and about 9. So for me, that tells me that I'm just going to leave this at about 95%. That probably gives us the best values of where we're at. And then we can go back, and the last thing we may do is, what if we try a different walking tolerance? What if we try, let's say 1,000 feet instead of 500? So now we're letting our users walk much, much further, so everything becomes fair game unless it's been allocated to somebody else. And by going up to 1,000, our difference went from 13 and 9 to 26 and 10 and a half. So it's telling me that our walking distance of about a block is probably a realistic and acceptable walking distance. And if we go up further than that, we may begin to overpredict how far people are going to walk in our model. So we can go back to 500. And I'll do that now, and we'll get back to where we were.
The better numbers at 350.
Was it better at 350?
When you were down to 11 and 6.
All right, let's try that. I'm going to run it at 500, and we'll be at 11 and 9. Let's try 350. And that's probably not unrealistic for the example that we're looking at, because everything's self-contained in this block, which is probably about 700 feet from side to side. We went from 11 and 9 to 12 and 7. So our standard deviation got a little bit better, but our mean difference is off a little bit. So we'll leave it at that. Now there's one last thing that we can do as a modeler to go in and adjust. We can look at some specific calibration correction factors, and I'll bring the let me bring the attribute table over here for you to see, and you can see what we're looking at. All right, so here we go. So in the attribute table, and I'll scroll back to the right or to the left here. What we have here, and this is going to be similar to what you might have in yours, maybe with different nomenclature for the occupancies, but we'll have the facilities listed that are in your system. And within those facilities, we have occupancies by different time of day. So for this particular example, I've got occupancies that were collected between 7 a.m. and 5 p.m. that we're calibrating to. And these are all the field observed occupancies based on different times of day. When the model goes through and does its prediction, it populates these fields, which are the calibrated occupancies, which represent what the model expects that facility to operate at based on all the parameters that we've just gone through and put in. And so what we're doing from a calibration perspective is looking at what is the difference between those two fields and how do we adjust those to better set our modeling parameters to better predict the occupancy on a facility by facility basis. And so we have a variable that we just call delta, and I'll show you what we do. We just do a field calculation, and we'll load this formula that basically looks at the difference between each of those hours for the facility. So occupancy at 7 a.m. versus the calibrated occupancy. And it gets us an average of all of those deltas over the course of the day for each of the facilities. So if I run that, you'll see that we have deltas of 6%, less than 1%, 19%, 15%, and 6%. And so what we can do for those that the deltas are high, where we have 19% and 14%, it's telling me that there's a negative 19, which means that it's over-predicting the demand there, so that the calibrated occupancy is higher than the observed occupancy in the field. And then there's the positive 14, which is telling me that it's under-predicting what the demand is, so the calibrated occupancy is lower. So what we want to do is go through and just set correction factors so that it is moving the parking to where it's supposed to be. And if we look at these on the map, it's basically these two blocks of on-street. So the model is using the land use data, and it's saying, well, I'm going to go there first, and then I'll go there. But in actuality, people are parking here first and then going there second, maybe because of arrival patterns, maybe because of proximity to land use. But because our factors are distance and price, it's weighting them equally and then allocating them in the order that it sees them in the attribute table. So we want to reverse that so that it's predicting it appropriately. So our model has a little bit better calibration, but it's also predicting their location better. So I'll go in and let's just start with, let's say, let's edit this. Let's see here. So this one's negative 19, so I'm going to start with negative 2, and this one's positive. I'm going to just start with 2. And we'll let's see what we get when we do that. We're going to go back to 350 because that's where we're at. Let's just do 500. It was a little bit better. Let's do that. All right. So with 500-foot walking distance and these correction factors, we should start seeing some iterative reduction in that mean difference and that standard deviation now. And we'll go through, and again, this is part of the lengthy process that we do where we'll go through and adjust those for facilities that are competing with one another to make sure that it's predicting correctly. So let's go back in now and see what those deltas are after the recalibration. So our negative 2 bumped that up to 51. So we went too high. Our 2s were a little bit too high of a factor, so let's bump that down. Let's make this negative 0.5 and make this 0.5. So we went too high there.
So the correction factor does not have to be a whole number. It can be
It does not, and that's a good question. The way our algorithm works is it weights that price and that distance based on a score of 1 to 10. So it's comparing parking facilities with other parking facilities that are available for a land use and scoring it anywhere from 0 to 10. And so your correction factor basically can be anywhere between negative 10 and 10. If you're doing negative 10, you're basically taking away all of the attractiveness of a facility. If you're going positive 10, you're accelerating that attractiveness by the maximum amount. But it can be any decimal number between 0 and 10 to adjust and get us back to where we need to be. So let's go one more time. We should be getting close now. All right, so we've gotten these down. So now this one's negative 0.24, so we're pretty much just working with this facility now. And let's see if we can't bring that down just a little bit. All right, so this is the last one. We'll see where it goes, what it gets us. But again, we work this process, and typically we'll get the raw data from your model and plug it in the first time, and we'll get something like 30% mean difference and standard deviations of 17, 18, 19, 20, and then we work through the process to get these down so that we're getting, again, mean differences between 5 and 10, standard deviations around 5%, and that gives us a model that is pretty well calibrated, is predicting where occupancy and demand are going to go, pretty close to the actual conditions that we saw in the field. So here, our model, after we put in those last correction factors, we got to 9 for mean difference, standard deviation of 6.8. And so that's one of those where now we're pretty well calibrated. We may go through a couple of other iterations to see if we can get it lower, but this is an acceptable level for us to go in and start running predictions from the model. So I'm going to stop there. Let's open it up to questions or discussion. The interesting thing is for most of you, if not all of you, well, all of you, will not have this version of the model. Your calibration was done in a secondary spreadsheet where we were outputting data from the attribute tables and running these same calculations, but doing them in the attribute table or in the spreadsheet and then bringing the data back in to the attribute table. So when you go in to start building these models again, it may be beneficial to just get this patch so that you have it to make it easier for you going forward. So with that, I'll stop. I've thrown a lot at you in 35 minutes. What are your thoughts or questions here? Anybody think they can go do this now?
I can do it.
It's an iterative process. Again, we've got folks here that do it. It takes a little bit of time to get through it, but I think what we'd like to do is, for those of y'all, and I talked to you about this, Kurt, but for those of y'all that are beginning to do recalibrations of your model, have you go and test this as a means of understanding, how easy it is on your end to do these types of things.
It just seems a bit daunting when I know I'm going to have 2,500 line uses that I'm going to have to balance out.
And that's the big thing, and so you have to go in and set those relationships as best you can when you start. If you've got office towers or you've got government office or things like that, having the ability to go in and set their relationships with the parking is the first critical step, and you should be able to get those. Once you get those set up, that should help to set that the calibration and the correction factors. But I mean, as an example, this is a small one-block subset of downtown Tempe, Arizona, that probably has 1,000 land uses and 200 parking facilities, including on-street block faces. And Sarah, who's on the phone, I think probably spent a good week calibrating this model and going through different iterations to make sure that what was predicting was correct, and then that the correction factors that were associated with it were allocating parking appropriately. So it's not an easy process, largely because it's time consuming.
Maybe this is a field, maybe it's a question for another time. But when you look at your parking structures, you select your parking structure, you have several different layers within three kinds of parking, whether it be for, let's say you had a parking structure A, and you had student parking, office parking, and then commuter parking. You would have three different shapes, and so I thought that in the past we could just go ahead and say, of that 1,000 parking spaces, 500 goes to this use. Is that still an option?
Yeah, that's exactly. So if you look at this example here, so this is U.S. Airways and then U.S. Airways Public. So U.S. Airways has 845 spaces and the public has 800. And with this one, it's a mixed-use public and private facility. So the U.S. Airways employees who are in the office adjacent have permits to park there, but there's no nested or reserved spaces. And so based on our understanding of the occupancy and talking with Adam, parking director down there in the city of Tempe, we kind of felt like it was about 50-50, and so we put 845 with the permit spaces and 800 with the public. And then there's occupancy and there's price data that are associated with both. But if you saw, I've got those two layered together, and then I've got just the U.S. Airways restricted to the office. So the public is serving the other demands around here. So there's another office building here, and there's retail and restaurant here that are largely being served by this facility. And then this one was the Monty's restaurant parking lot, and it serves only the Monty's restaurant. So you have the ability to layer those so that you've got, if there's 4 different types of users in a facility, you can set those up so you allocate them appropriately.
Right. I think the question was, is that do you need to have the 4 separate layers, or can you have one layer and then allocate it out from your total?
Yeah, you're going to need to have if you're going to have part of the facility private and allocated to a land use, you'll need to have that as its own separate layer or line in the attribute table, so that you can take that line and separate it out from the rest of the capacity. And then the rest of the capacity is still public serving. Does that make sense?
Sure does.
Okay. What else? I hope that that's because it makes sense, but I mean it's a somewhat convoluted topic in terms of, you know, kind of managing the data and bringing it all together to give us the results that allow us to really understand, you know, how to start predicting things. One of the things we're working on right now is a white paper that documents all of these things. You know, just because it is a black box if you're looking at it from the outside, and we want it to be less of a black box and more of a intuitive process of understanding how we get from your data to a calibrated data set. So I'm hoping that the combination of this Lunch and Learn, which will be on the user group website by the end of the day today, this recording, and the white paper starts giving you a little bit better sense of where to go. Yes, I'll ask Cynthia. I mean, you're getting ready to do a recalibration of a model, and you're going to start with building data sets. But does this seem intuitive enough that you could go in once you've got those data sets built and start calibrating?
I feel like I'm going to need a lot more help. It still feels very new to me.
Right, and that makes sense.
And I'm not because I'm still getting familiar with the parking data and its relationships to get to a point of where, like you were mentioning about a standard deviation between 5 to 10 is a good place to start, for an acceptable place to start for a good calibration. I mean, I wouldn't know what those percentages would be. You know, when is it good for me? Okay, I got a good one going now. I can build on top of that. It's still a black box mentality for me.
Understandable, and those percentages come from kind of testing your previous data as we've built out this module, along with, you know, again, those discussions with travel demand modelers who have been doing this from the street network, road network realm for a long time now, and they kind of helped us define, you know, how to set up those correction factors for calibration that would be similar to a weighting that you would do for facilities in a travel demand model, and then what those percentages needed to be for acceptable levels. And so that's, I mean, we give you a window. It's, you know, 5 to 10% is a good place to be. You know, sometimes data may not allow that, and I'll give you an example. We're doing a model right now for Salinas, California, and in Salinas, they didn't want to go out and collect new parking occupancy data. They wanted to take occupancy data from a previous study, which was done in 2007 and then an update in 2009, and plug that data into the model and calibrate to that. We weren't quite able to get it to between 5 and 10% on that standard deviation, just because the data that we were predicting was not the same as the same time frame as the land use that we were predicting to. So we got it down to 12 or 13% and kind of had to go with it from there. But for those of y'all that are going out and collecting data or have data at your disposal, you should be able to get this into a fairly decent calibration. And again, you know, we're always available to help with that in terms of just walking you through the process, doing webinars, one-on-one, those types of things, like we've been doing with the City of Houston for a while now. So, you know, take advantage of that if you can.
We will.
No worries. I know you will. So I mean, that's pretty much it for the calibration side of things. What are any other questions or concerns anybody's having with their model right now that you want to talk about? Is everybody generally using the model right now? I know a few of you. I know Kurt's building out a new data set, and we're working with Eric right now to do an updated Texas A&M model. What about the rest of you? You know, Durham and ASU, have you had a chance to get in and get your hands dirty a little bit with the model?
Reggie Johnson, Durham, have not gotten to that point yet. Still have some political issues around determining the parking.
Fair enough. I can understand that. All right. Well, I hope this was somewhat helpful. I mean, I know we threw a lot of information at you. Again, this is going to be on the user group site as a resource for you to be able to go in and access. The next one of these we're going to do is going to build off this series, and so in a month or two we'll do one related to developing scenarios. So now that you've got a calibrated data set, what does that mean from scenario development? Adding land uses, adding parking, setting up the characteristics for that scenario and running it to do predictions. And so the intent is by the end of the year, we've done a series of about 5 or 6 of these that'll walk you through the entire process and give you a little bit more detail that you can find in that binder that we left with you. And, you know, again, we're also working on other things to help you out. Based on some comments from a recent user group meeting in Texas, we're working on a little more of a streamlined process for what do you do for different scenarios. So instead of having to turn to the manual and try to find something, this is a kind of a cheat sheet of, if I'm doing this, here are the steps to do this. And a lot of that's coming from questions you've been asking, webinars we've been having with the City of Houston, emails that Kurt's been sending us as he's been building out. And so we welcome you to continue doing that, because that's going to feed the entire user group better information as we go forward. So with that, if there are no other questions, we'll wrap today. You know our lines are always open, so if you have issues or you have trouble, email me or shoot me a phone call, or any of the other Kimley-Horn folks that are on this today are more than helpful getting you set up and running these things. So I thank you today. Let us know if you have any questions, and we'll be talking in a month or two.
Thanks, Brad.
Thank you all.
Thanks, Brett.
Thank you.
Thank you.
Bye.